Okay, guys, do you have any questions on that one? So you basically just had to fill in that table first, and it was quite an easy one to do because you were just adding 2 every time, right? So that was the constant difference there was 2. So you can see that if you want to fill it in, it was +2, +2, +2. So to get to the next one, you're going to have to add 2 again. To the next one, which is 6, you have to add 2 again, and then you're going to add 2. To get to 10, you can either decide to add 2, 3 more times, or you can come up with a rule and then use that rule to find 10 and 30 and 60. So we know that if our constant difference is 2, then we're going to have 2n in our rule, right? So 2n is 2 times the shape number. Now, what is 2 times this shape number? 2 times 1 is? 2 times 1? 2. What must I add to 2 to get 3? 1. So that's why it's 2n plus 1. Okay, when you have that, you can use that to find 10 and 30 and 60. You just say 2 times the shape number and then you add 1. Then they ask you to draw or make a graph of your findings. You couldn't actually fit all of them in there unless you used a different scale. I'm not sure what you guys did. I just went with 1 block is 1 unit. But that meant that I couldn't fit in 30 and 60. I couldn't fit in those last 2. Did anyone else do something different? Did anyone use a different scale to try and fit them in? It's not, yeah, it's fine if you didn't. It's okay. You can see I just wrote my scale in here. So I didn't write 0, 1, 2, 3. You could have done that if you wanted to. I just labeled every second one because the space was a bit limited there. But basically, they want you to, if your shape number is 1, your number of pebbles was 3. So you're going to go at 1 and then 3, and then you have a point there. Okay, but you guys have done graphs like this in bio, so you should have been fine. If your shape number is 2, your number of pebbles was 5. So you go to 5 there and you plot a point there. And guys, do you notice that we're getting like a straight line here? Right? If we were to draw a line through all of those points, it would actually give us a perfect straight line here. Okay, cool. Thank you. Okay, now in grade 9, I'm actually busy doing it with my grade 9s at the moment. You are going to learn how to draw straight line graphs, and then you'll see that a straight line graph equation always has this kind of form, where it's a number with an x in that case, and then another number. So yeah, just looking ahead, I think that's why they wanted you to plot these points. Okay, but only towards the end of grade 9 will you work with that stuff again. Okay. All right, guys, any final questions on number patterns? We are done now. Some of these questions were a bit iffy. All right, some of the questions in these worksheets, and I said also when there were strange questions or silly questions, like those ones where they're saying, how would you convince someone that it works? We obviously won't ask you something like that. Where they're asking you to find an answer using multiple methods, we won't ask you something like that. Where they're giving you, like even this one, activity 16, where you don't actually have values to work with, you have to kind of guess. We also won't give you stuff like that. All right. It will more be like actual finding the rule, using the rule, answering questions. That water and that telephones exercise, those are nice ones, important ones. But yeah, there were quite a few iffy ones in this set. Okay. All right, guys, we're going back to some algebra. I'm sure you're very excited about that. So please make a new heading, algebra. Let's say algebraic expressions rather, that sounds more formal, I suppose. Algebraic expressions. Okay, we are going to work with division today, which we have kind of done. There's just a specific type of division that we haven't done yet. So division. We're just going to jump into some examples and then you'll see what I'm talking about. Simplify the following. It is a fraction. I'm just writing it over 2 lines. Okay, guys, am I right when I say that you have seen questions like this before? Right, where it's one term and you have to divide it by one term. That's important. I don't think we might not have emphasized that in the past, but it is going to become important now when we do other types. So we have one term in our numerator and we have one term in our denominator. Now guys, we have numbers, we have x's and we have y's. Okay, do you remember that we're going to do them all separately? So we're going to say, what is 24 divided by 4? 6. Okay, so my answer has to have a 6 in it. Now we have x cubed divided by x squared. Do you guys remember how that happens? I'm just going to do it on the side here. If we have x cubed divided by x, remember x cubed is the same as x times x times x. Is that correct? Right, that's x cubed. And if you divide that by x, you can cancel out. You can divide one of the 3 x's at the top and that x at the bottom. And what is x divided by x? Just 1. All right, so this becomes x squared times 1, essentially. We don't usually write that one. Okay, so this is just actually equal to x squared. All right, so that is where that x squared comes from. And then what is y divided by y? What's anything divided by itself? 1. So is there going to be a y in my answer? No, my answer is 6x squared. Okay, I'm going to do a few more. Number 2. Again, we have one term at the top and one term at the bottom. What is 15 divided by negative 3? What's a positive divided by a negative? It's a negative, right? So we know that our answer definitely has to have a minus in front. 15 divided by 3 is 5. Then we have an x at the top. Is there even an x at the bottom? No. So that x at the top can't be cancelled out. I can't divide anything by it, or I can't divide it by anything rather. So my answer is just going to have that x in it. We have y squared at the top and y at the bottom. So guys, if I have y squared, that's saying that I have 2 y's at the top, 1 y at the bottom. The 1 y at the bottom is going to cancel out one of the 2 y's at the top. So if you want, you can draw a line through the y at the bottom, and then you can draw a line through that exponent of 2. Okay, because that is what's being cancelled out. The second y is being cancelled out by the y at the bottom. But I do still have one y left in my answer. We have z cubed over z squared, so 3z over 2z. The 2z's at the bottom are going to cancel out 2 of the 3z's at the top. How many will be left? 1. So that 1z is going to go in my answer. If you want to, you can draw a line through the z squared and again a line through that exponent, because that's what is being cancelled out. We're just left with the z. Okay, and that is the final answer, guys. I want us to do one more. No, let me see. Yeah, one more. I'm going to do it on the side here to save some space. 35 x y squared z to the 7 Do I have one term at the top? Okay, one term at the top, yes, and at the bottom, also 1. Okay, so it's the same as the previous 2 examples. One term, one term. What I do want you guys to notice now, though, and you might not notice it straight away, but before we start writing our answer, let's just look at what we have. We have 35 divided by 5, which we can all do. We have an x at the top, no x at the bottom. Let's look at what's happening with these y's. We have 2 y's at the top, but 5 y's at the bottom. Do we see that we have more y's at the bottom than at the top? In the 2 previous questions, we always had more of a specific variable at the top than at the bottom. Now, what do you guys think is going to happen if I have y squared and y to the 5? I have 2 y's at the top, 5 y's at the bottom. I'm going to do it on the side here. Y squared over y to the 5. So that is the same as y times y over 5 y's all multiplied together, right? This y can cancel out that y, that's fine. The second y can cancel out that y. Where do I have y's left, guys? At the bottom of the fraction. Do you see I have 3 y's left at the bottom of the fraction? So in my final answer, I have to have y to the power of 3 in the denominator. Okay, because there are more y's at the bottom than at the top. So when you cancel them out, you're left with y's at the bottom. All right, so our answer, I'll be with you now, is actually going to be a fraction in this case. In the previous ones, they were just, it wasn't a fraction. In this last one now, in number 3, we do have to write our answer as a fraction because we're going to have y to the power of 3 at the bottom. Eve? Yes. Yes. Yeah, exactly. Yes. So guys, it is useful before you start writing your answer to actually check, are there any variables that you have more of at the bottom than at the top? Because if that is the case, you're going to have to write your answer as a fraction. Nicholas? No. Oh, you're stretching. Okay, so let's do this, guys. What's 35 divided by 5? 7. Now the 7 goes in my numerator. Okay, because the 35, we are dividing by 5. 35 is bigger than 5. Okay, so we put that in the numerator. X at the top, is there an X at the bottom? No, so we're left with an X at the top. Like we said already, we have 2 y's at the top and 5 y's at the bottom. So the 2 y's at the top are going to cancel out 2 of the 5 y's at the bottom, and we'll be left with 3. So we're going to have y to the power 3 in our denominator. We still have z's to look at. We have 7 z's at the top, 5 z's at the bottom. Where do I have more? At the top or the bottom? At the top. So I'm going to be left with z's at the top. How many am I going to be left with? 2. Hey, because it's 7 at the top, 5 at the bottom. So if the 5 at the bottom cancel out 5 of the 7 at the top, I'm going to be left with z squared. And that is the answer there. Okay. I just felt like I needed to remind you guys of these types of examples before we move on to the new ones. So example 4. How many terms do I have now in my numerator? 2. That's different, hey? We actually have 2 terms now. But in my denominator, I still have 1 term. Now, guys, what this fraction line actually means, I think we all know this, is that it means division, right? But if you have more than 1 term at the top, what the fraction line is saying is that the whole numerator, so both of the terms in the numerator, have to be divided by x. Okay? So what we're actually going to do is we are going to write this as 2 separate fractions. I'm going to say I'm taking the first term in my numerator and I'm going to divide it by x. Yeah. Well, we can't in this case. Sorry, thank you for saying that because I forgot to mention that. Guys, do we see that these are not like terms? 10x squared and minus 3x. All right, they're not like terms, so I can't subtract them. But if they had been like terms, you would simplify that first. Okay, thank you, Eve, for reminding me. Does that make sense, guys? So they're not like terms, so then we're going to do each term separately. So you take the first term divided by x, and then there's a minus, so I'm going to put a minus in between the terms. 3x is the second term. I'm going to divide that by x as well. Does that make sense, guys? So we are physically showing that I'm going to take each term and divide it by that denominator by x. All right, so in a sense, we're splitting up the fraction. All right, now we need to do this division thing twice. 10 divided by 1 essentially, right? That's going to be 10. And what is x squared divided by x? Just x, good. Minus, what is 3x divided by x? What happens with the x's? They cancel each other out, right? So it's 3. So we are left with 10x minus 3. Right, but guys, you have to do that. You have to divide every single term. Even if you have 12 terms in your numerator, you would have to divide all 12 of them by that one denominator. Okay, we're going to do a few more examples. Actually, just one more. So I'll do it on the side here. Oh, sorry, that's supposed to be a Z. Yes. Do we notice that we now have 3 terms in the numerator? Right? 1, 2, 3. Remember, pluses and minuses separate terms. Okay, so I have 3 terms. And at the bottom, again, I have only one term. Now, guys, in grade 8, we won't give you more than one term in your denominator. Okay, so it will always be, it can be any number of terms at the top, but your denominator will always only be one term. Okay, in grade 9, we're going to teach you how to work with more than one in the denominator. Okay, so we know that the fraction line means division, so I have to divide everything at the top by negative 4z. So I'm going to say 24xz over negative 4z. That's the first term. Plus the second term, 16yz over negative 4z. Now I'm going to put a minus in front of the next one because there's a minus in front of that third term, all right? Or the third term rather is a negative term. So negative 4z over negative 4z like that. Okay, if we're looking at that first fraction, what is a positive divided by a negative? Negative. 24 divided by 4 is 6. There's an x. Is there an x at the bottom? No, so the x has to be in my answer. And then those two z's will cancel out, right? Z divided by z is just 1. So the first term is negative 6x. Now, guys, what I want you to do in the next case, you could say plus and then write your answer in brackets, but let's just actually take a look here. What is a positive multiplied by a negative or divided by a negative? It doesn't really matter how you look at it. It's negative, hey? Because, guys, if we wanted to write this fraction, if this was just a fraction on its own, right? And we wanted to simplify it, do we agree that it will be negative? Because there's a positive term at the top and a negative term at the bottom. What's a positive divided by a negative? Negative. So that whole fraction, in fact, is negative. But what is in front of that fraction? A plus. So what is a positive multiplied by a negative fraction? Negative. So what I'm going to do is I'm just going to make that whole thing negative right from the start. And then I've already sorted out that minus. Okay. Now we don't have to think again, what is a positive divided by a negative? We've already sorted out the minus. What is 16 divided by 4? 4. There's a y at the top, there's no y at the bottom, so we're going to have a y in the answer. And again, the z and the z will cancel each other out. Z divided by z is 1. So my second term is negative 4y. Now, guys, if you didn't want to do what I did now with the signs, you would have had to say negative 6x for your first term, then plus, and then in brackets, negative 4y, like that. Because the fraction on its own, if you were to just simplify the fraction on its own, it will actually be negative 4y, right? But there's a plus in front. So you would have to do it like this. Okay, which is fine. You're just going to have an extra step at the end where you then do positive times negative, it's a negative. Okay, let's look at the next fraction, guys. Here we have a negative in front, and this whole fraction, again, is going to be negative, right? Because it's positive divided by a negative. So we have a minus here multiplied by a negative fraction. What's a negative times a negative? A positive. So this is going to become a plus. All right, and now I'm done. And now I've sorted out my signs. Okay, I don't have to do that again. What's 4 divided by 4? 1. And what's z divided by z? Also 1. So what is this? 1. Anything divided by itself is 1, right? And you can actually say that this is 4z divided by 4z. So the answer there is 1. Okay. All right, guys, your homework is just going to be division questions. You have a whole half hour now to work on it in class. I'm sure you will finish it in that time. So I'm going to put it on the board. It is from the algebra worksheet, which is on your Google Classroom. I'll show you now where to find it. I posted it there in the past for revision for you, but now I'm actually going to set one of those questions. I think it's question 4. I'll show you now, but then I also want you, if you are done with question 4, to move on to question 5, which is a mixed exercise. So that tests addition, subtraction, multiplication, and division. But yeah, I'm not sure how long the division stuff is going to take you guys. Just write that down and I'll show you where to find it. And I'll put it on the board as well. Okay, guys, if this is your maths Google Classroom, right? The N8 one. If you go to classwork, you'll have to go on the topics here on the side. You'll have to click on algebra. And then it's the only thing that's there. Okay, the algebra, I suppose, algebra revision worksheet. If you click on that, you see what I'm talking about. Question 1 is addition and subtraction. You're not doing that. Question 2, we might come back to that later on, but not now. Question 3, you're also not doing. Question 4 is the division one. Okay, so there are 15 questions. I'm not sure how long it will take you guys. If you finish these 15 before the end of the lesson, then you can carry on to question 5. Okay, which is a mixed exercise. You can see that there's multiplication, addition, there's some division, there's some exponents with brackets, and there's also multiplying numbers into brackets. Do you guys remember that we did that once upon a time as well? Okay, so you have more than enough to do now. I am just, yeah, there we go. I've zoomed in. You're going to do question 4. If you can't see that, then you'll have to just open it on your phone and look at it there. Okay, which is fine. I showed you now where to find it. You can listen